In this video, we will practice finding the derivative using the chain rule. The chain rule is useful for when you can view a function as the composite of an inner function and an outer function. In this case, I've shown the inner function in red and the outer function is in blue. So if you want to find the derivative using the chain rule, you first take the derivative of the outer function and then you multiply it by the derivative of the inner function. So let's start with the outer function. The power rule says we move the 3 to the front and reduce the power by 1. So at this stage, we leave the inner function the same, 3x squared minus 2 over 2x plus 3. But then we multiply by the derivative of the inner function. This is a quotient, so we're going to have to use the quotient rule. Let's remember the poem that helps us remember the quotient rule. Low d high, less high d low. Draw the line and down below, the bottom squared will go. So let me go through that again. Low d high. Low means, let's just write down what we have in the bottom. So 2x plus 3, that's low. And then d high, that means the derivative of the top part. So the derivative of 3x squared is going to be 6x, and that's it. So this is low d high. So low d high less high d low. Less means subtraction. High means we're going to write down the top part, which is 3x squared minus 2. D low. Now we're doing the derivative of the bottom piece. So that's going to be just 2. Okay, so I've got low d high less high d low. Draw the line, and down below, the bottom squared will go. So you see the bottom sitting there, so we'll just put 2x plus 3 squared. Okay, so that was a lot, but just to review, first we did the derivative of the outer function, shown here in blue. So we put the 3 in the front, and we reduced the power to a 2. Then we multiplied by the derivative of the inner function, which is what you see over here with the quotient rule. So guess what? If this is a free response question, you can leave your answer in this ugly form. In fact, I would recommend it because why take the chance that you're going to make a careless mistake while you're simplifying? However, sometimes it'll be a multiple choice question and you will have to simplify in order to match your answer. So I am going to simplify this just to show you how that would be done. So I'm going to go ahead and multiply this out, and I'm going to multiply here. So I'm going to do a little of that off camera. So far I distributed in the numerator like I said I would. I also split this up with the numerator and the denominator. I squared each separately, so that on my next step, I can combine these into one fraction. Since the 2x plus 3 appears in both denominators, when I multiply these, you're going to see it become 2x plus 3 to the 4th power. And I will combine like terms in this expression right here. I'll just do one more step here. Notice that in this trinomial, all terms are divisible by 2. So I'm going to factor out a 2. It's going to multiply by this 3. So you'll see this become a 6. So here is a more simplified version of the answer in case you need to recognize it on a multiple choice question. I colorized this so you can see the outer function in blue and the inner function in red. So according to the chain rule, when we find the derivative, we first take the derivative of the outer function. The derivative of sine is cosine. And you leave the inside the same. but then you multiply by the derivative of the inner function. So the derivative of pi x is just pi. And I would probably put that pi in the front. So y prime is pi cosine pi x. All right, that was a lot easier than the last one. I colorized number 48 so you can see that the outer function is just the cosine, and everything here in red is the inner function. So the cosine is not being squared, just the 1 minus 2x is being squared. All of this is inside the cosine. So as we do our derivative with the chain rule, first we do the derivative of the outer function. The derivative of cosine is negative sine. So I will write negative sine, and then I will leave the inner part the same. So I have my negative sine, and then 1 minus 2x squared. But then I need to multiply by the derivative of the inner part. Did you notice that the inner part has another function inside? So we're going to have to do the chain rule again. So to do the derivative of all of this, first we do the derivative of the outer part, which is the squared part. So we're going to put that 2 in the front. So now we've taken the derivative of the outer part, and we leave the inside part the same. But then we multiply by the derivative of the inner part, which is negative 2. On the next step, the negative and the negative will make a positive, and 2 times 2 will make a 4. However, I would like to move this entire factor to the very front. That way it doesn't look like this expression is inside the sine function like this expression is. So the final answer looks like this. I don't think I am going to use the chain rule on number 52, but I am going to rewrite this before I take the derivative. I really am going to move this cosecant up to the numerator and make it sine. Some people aren't comfortable with me just doing that, so I'm going to show this extra step. So we've got cosine v in the numerator. We know that cosecant is the reciprocal of sine. So this would be the same thing as 1 over sine v. And when you're dividing by a fraction, you multiply by the reciprocal. So this would be the same as g at v is cosine v times sine v. I'm just multiplying by the reciprocal. So I'm going to find the derivative by doing the product rule. So according to the product rule, if I do the derivative of function g, I'm going to take the derivative of the first factor and leave the second factor alone. That'll be the first step. So the derivative of cosine is negative sine. And for now, I'm just going to leave the second factor the way it is. So times sine v. And then I do a plus. And then I go through it again, but this time through, I leave the first factor alone, and I do the derivative of the second factor. So this is me leaving the first factor alone, cosine v, and then the derivative of sine is cosine. So I have cosine v. So this is the answer. You could just put a box around this. If this were a free response question, this would be an acceptable answer. But it's easy enough to simplify this a little bit, so I'm going to do that. This would be the same thing as sine squared. So I have negative sine squared v plus cosine squared v. Now, If I swap these terms, you might recognize this as an identity that you should have memorized. So just reversing the terms, I have cosine squared v minus sine squared v. Does this look familiar? It should. This is one of your double angle identities. There are three versions of the cosine of 2 theta, and this is one of them, cosine squared minus sine squared. So this is the same thing as the cosine of 2v. So if this were a free response question, you could have put the first version that I put in a box, or you could put the line below that or the line below that. But you need to understand, if there were a multiple choice question, the answer might be written this way. So you need to recognize that. Just for your reference, here are those double angle identities I was talking about. You might want to pause the screen, write these down, study them. Make sure you have these in your brain still, back from pre-calculus. This is another double chain rule where we have a function inside of a function inside of a function. So before I take the derivative, let me rewrite it with different colors so you can see the three levels. In fact, first of all, when you have cosine squared 8 theta like this really means that we have cosine 8 theta, and that whole thing is being squared. So first of all, that's what that means. Now here come the colors. So this squared business is the outer function, and then the next layer in is the cosine, but then inside of the cosine we have that 8 theta. So according to the chain rule, when we take the derivative, first we do the derivative of the outer function. So we will do the derivative of the blue, which will be 2 times whatever is on the inside. And when we do this step, we leave the inner part the same. But then we multiply by the derivative of what's on the inside. So the next layer in will be the cosine. Maybe I'll put some extra parentheses in here to make it clear what's inside of what. So it's time to take the derivative of cosine. But the derivative of cosine is negative sine. Okay, so now I've taken the derivative of the red layer. Right now we leave the inside part the same. But we then multiply by the derivative of the inside of that. And the derivative of 8 theta is just 8. So right now, what you see here is the answer. This is the derivative. Were this a free response question, you could just leave your answer like this. Having said that, I am going to simplify it a little bit. So we've got 2 times 8, that's 16. See the negative there, so that'll be negative 16. What else? Then we've got cosine 8 theta and sine 8 theta. So this is a simplified version of the answer. I almost missed it, you guys, but there is another version of this answer that you are likely to see on a multiple choice question. To make it more obvious, I'm just going to flip these around real quick first. So obviously this is the same as negative 16 sine 8 theta cosine 8 theta. See this first double angle identity right here where we have 2 sine A cosine A? So if I see 2 sine cosine, I can rewrite that as sine of 2x or theta or whatever it is. I see the sine cosine, and I could easily rewrite this as 2 sine cosine. So I'm going to do that real quick. So I could write this as g prime is equal to negative 8 times 2 sine cosine. Okay, I'm purposefully leaving the parentheses blank for a second because I don't want you to be distracted by the fact that there's an 8 theta inside. So I'm just going to leave these blank. But you see that this part right here is 2 sine cosine. And when we have 2 sine cosine, we can write sine of 2 theta. So that's what I'm going to do. So I can rewrite this. I have to keep the negative 8, but this yellow stuff is going to be sine of 2 times, like if this was theta, then I would say sine 2 theta. But it's empty, so I'm just going to have sine 2 empty. But wait a minute, what does actually belong in there? Well, it was 8 theta that was in there. So I'm going to go ahead and put the 8 theta back now. So I have 8 theta in here too. So it's sine 2 8 theta, which can be multiplied. I'm going to need a tiny bit more space here, I see now. So the final, more simplified answer would be negative 8 sine 16 theta. So you might see this version on a multiple choice question. So watch out for it. When we take the derivative on number 60, it's going to start off normal, but when we get to this area over here, that's when the chain rule is going to start to happen, because we have this function inside of a function inside of a function business happening. Yeah, that's true. So we'll have y prime equals. First we take the derivative of the 3x. That's just 3. We're also going to just leave that constant in the front. That doesn't need to be bothered. So here we go with a function inside of a function inside of a function. The outer function is the cosine. So we're going to go ahead and take the derivative of that, and that will be negative sine. The derivative of cosine is negative sine. So I'm going to put sine here, but because it's negative sine, it's actually going to turn this into a positive. So I took the derivative of the cosine. And for now, I'm going to leave the stuff inside alone. So we still have this pi x squared. So next, we need to take the derivative of this red stuff inside. But this is still chain rule, where the outer function is the 2. So I'm going to put the 2 in the front. So that will become like this, and the stuff inside is going to stay the same. Except then we need to multiply by the derivative of that stuff inside. So I'm going to multiply by pi. So it's that double chain rule again. So I'm just going to clean this up a little bit. So far I just brought down the 3. So all of this stuff that's outside of the sine function can be sort of combined. So I've got the 5 times 2, so I'm going to have a 10 sitting here. But then I've got a pi here, and I've got another pi there. So that's going to be pi squared. and then we've got the x sitting there. So I've got 10 pi squared x. All of that in front of sine pi x squared. So this would be a decent version for your answer. Find and evaluate the derivative of the function at the given point. So I'm going to rewrite this first. So I don't have to use the quotient rule. I'm just going to bring this denominator up with a negative power. So I will have x squared minus 3x to the negative 2 power. So now I am ready to do the chain rule. So f prime equals, first we take the derivative of the outer function, which is the negative 2 squared part. Well, negative 2 power part. So I'm going to take that negative 2 and put it in the front, and I'm going to reduce this power by 1 so it becomes negative 3. Meanwhile, I leave the inner part the same, x squared minus 3x. So I've taken the derivative of the outer function. Now I multiply by the derivative of the inner function. So the derivative here will be 2x minus 3. And that's it. So you really could leave your answer like this if you wanted to. Except wait, we were not simply asked to find the derivative. We are supposed to also evaluate the derivative at the given point. So this function, this derivative, is in terms of x. So when we evaluate, we really are just substituting the 4 for these x's. So we have this so far, but let's simplify this down and see what we get. So we're going to have negative 2 times 16 minus 12 to the negative 3 power times 8 minus 3. And then 16 minus 12 is 4, 8 minus 3 is 5, so we have this. The 4 to the negative 3 power, let's just drop this down to the denominator. Okay, so we're going to have 4 to the 3rd power in the denominator. That's going to leave the negative 2 times 5 in the numerator. So this will be negative 10 over 64. So you could leave this as your answer. Nothing wrong with that. Or you could reduce this. So this would be negative 5 over 32. Let's do that again for number 72. First, let's rewrite the function a little bit. 1 over x, that's the same as x to the negative 1 power. And then the square root of cosine x is the same thing as cosine x all raised to the 1/2 power. So now we are ready to find the derivative and later to evaluate. So using the power rule, we're going to put this negative in the front, reduce this power by 1, so this will be the negative 2 power. Moving on to the cosine, time for the chain rule. First we do the outer function. The derivative will put the 1/2 in the front. Reducing this by 1 will give us the negative 1/2 power. At this moment you leave the inside part the same, but you then multiply by the derivative of the inside part. The derivative of cosine is negative sine, so we're multiplying by negative sine x. So this is an expression for the derivative right now. And I might even just leave it like this until the next step. So now we are supposed to evaluate this at the point pi over 2 comma 2 over pi. But really, it's only the x value that matters. So we're going to take that x value and plug it in. So I'm going to get y prime equals negative pi over 2 to the negative 2 power plus 1/2 times the cosine of pi over 2 to the negative 1/2 power times negative sine of pi over 2. I just realized there's a little statement I need to add in here before I put in the pi over 2 for all the x's. I need to say at x equals pi over 2. If I don't say that, it looks like I'm saying this is the function for derivative now. This is about to just be a constant. If I'm saying that the derivative is a constant, that would mean a horizontal slope. And that's not the case. This is just the slope at one specific value. So you have to make this little statement before you plug in something for all of these x's. So I'm also going to rewrite this to deal with these negative exponents. Remember one little thing. If I have a over b to the negative 2 power, that's the same thing as b over a to the positive 2 power. So that's what's going to happen right here. What happened in this area here is, you see the 1/2, so the 2 is still right there. But then we have the cosine pi over 2 to the negative 1/2 power. Because of the negative, I had to drop this whole expression down into the denominator. And if I have cosine pi over 2 to the 1/2 power, we know that is the same as the square root of cosine pi over 2. So that's why when you combine those two things, I end up with 1 over cosine of pi over 2. All right, square root because of the 1/2 power. It's in the denominator because it was negative. This is going to be very important because of what's going to happen next. Think about what the cosine of pi over 2 is. So here's a small diagram of my unit circle. Remember that pi over 2 is up here at the top, and cosine is the x value. So the x value here is 0, right? This is the point 0, 1. So the cosine of pi over 2 is 0, but that's going to be a problem. So I really don't even need to write the rest of all of this. I just need you to understand if I have 1 over 2 times the square root of 0, I'm dividing by 0, guys, right? Because square root of 0 is 0. So this part is 1 over 0. This is no good. You can't divide by 0. So that means that the derivative at this particular x value does not exist. I went ahead and simplified this and put 4 over pi squared. The sine of pi over 2 is 1. So with the negative sine of pi over 2, that became the negative 1 that you see. But of course, the answer is does not exist because of this 0 in the denominator.